In this video, we'll be going over intersection of two linked lists. So given the head of two syncing linked lists, head A and head B, return the node at which the two lists intersect. The two linked lists has no intersection at all, return null. So in our first example, we're given these two lists, which is A and B, and then the difference of length of the two linked lists may be different, and then we want to find the intersection, which is at node 8 here. Let's go over the thought process. So we are trying to find the intersection of two linked lists. We should note that the two input lists may have different lengths, which we're going to call X and Y. We should know that we want to start at the same starting location. We will want to start at the starting location where the length of the list are the same. So if we're given these two lists, we want to start at these two same locations, and then we can just move forward both nodes at the same time to find our intersection. Now, how can we find these two locations? So we will want to move forward the longer list by the difference of the two lengths. We can just call it absolute value of x minus y. If we move forward the difference, we can get to the same starting location. So for example, in this list, one of the lists has a length of 5 here, and then the other list has a length of 6, and then the difference is 1. So we just move forward one step, and then we can start from this node, and then we can just move both at the same time to get our intersection. Now let's go over the pseudocode. So we want to find the length x and y of the two input lists. Now we want to determine which list is shorter and which list is longer. So determine the shorter and longer list using x and y. Now we want to move forward the longer list by absolute value of x minus y steps. This will allow us to get to the starting location where the lengths are the same. And now we want to move both pointers forward at the same time to find the intersection. So while shorter is not equal to null and shorter is not equal to longer, we want to move both pointers at the same time. So I want to set shorter to shorter.x, and then want to set longer to longer.x. Then we can just return shorter. In this case, we will either not find an intersection or finding an intersection. Now let's go over the time and space complexity. For the time complexity, initially we're finding the length of the two input lists, so n plus n, and then want to move forward the longer list by the difference of the two input lists. So we can just say O of n, and then we can just plus O of n, where n is the longer list. Actually, we can just say 2 times n. 2 times n, this is finding length. Finding length plus moving forward the absolute value number of steps. And then also our O of n is moving both pointers forward. Now let's go over the space complexity. The space complexity is O of 1 because we did not create any extra data structure. Now let's go over the code. So we'll first find the length of the two input lists. Now we want to determine the shorter list using x and y. So if x is smaller than y, then head A will be the shorter list and head B will be the longer list. And then we will want to find the longer list, which is basically swapping the parameters. Now we want to move forward the longer list by the number of steps. So move forward the longer by the absolute value the absolute difference between the lengths of the two lists, and then want to move both lists forward at the same time. Then we can just return the intersection if we find it, or just return null if we have failed to find the intersection. Now let's implement the methods. The first method we need is our getLength. We're going to create a variable length to keep track of the length, and then we iterate through the nodes of the list. Then when increment the length every single time we find a node, then we just return the length. Now the second method we need is moving forward on longer lists. And also the number of steps. We initially start with the head node, and then while step is greater than 0, we want to move node forward, and then we want to decrement the number of steps available. Then we just return the node. Let me know if any questions in the comment section below.